Welcome back to my house. Today we are going to be looking at Chapter 12, Lesson 5. It is on secant angles. You might wonder, what is a secant? That's not a word that we have used before. It is a word that is particular to circles, and it's another sort of line segment that is related to a circle, like a radius or a diameter or a chord or a tangent. This is another line segment. Maybe a line is a better word that is associated with a circle. So a secant is simply a line that intersects the circle in two places. Not tough. A secant is a line that intersects the circle intersects a circle in two places. If this is circle O, then I have this secant A, B, and I can draw another secant, and we'll call that C, D. When I have two secants that intersect in a circle, you can see that I now have four arcs that are cut off in this circle, right? 1, 2, 3, 4. Those four arcs are cut off in the circle. Does it look like any of those arcs are the same? Not necessarily. How about these angles that are formed here in the middle? I have four angles that are formed by those secants inside of the circle. Are any of those angles the same? Yes. In fact, angle C, let's call this P, point P. Angle CPB is equal to angle APD. Those angles are equal because they are vertical angles. And similarly, BPD is equal to CPA because those also are vertical angles. So we're going to be talking about the angles and the arcs that are formed when we have secants going through a circle. If you look in your book on page 511, you will see four figures across the top of the page. I want you right now to just look at the first two, figure 1 and figure 2. You can cover up 3 and 4 if they're going to be a distraction to you. Just look at those two pictures. You can see in figure 1 and in figure 2, we have a 60-degree angle inside of the circle that's marked. What are the sizes of the arcs that those 60-degree angles cut off? That would be the arcs across the top and the bottom of the circle. In figure 1, those arcs are 80 degrees and 40 degrees. And in figure 2, those arcs are 100 degrees and 20 degrees. How can I use those numbers to get to 60 degrees, which is the measure of that angle formed by the secants? You might see that if I average 80 and 40, I get 60. That is 80 plus 40 equals 120 divided by 2 equals 60 degrees. And similarly, if I average 120 from figure 2, then that also is 60 degrees. 100 plus 20 is 120 degrees. Divided by 2 is 60 degrees. So each of those angles of where the secants meet is a 60-degree angle. Now there are two other angles in those figures that are not marked. Well, actually, I guess just the one angle is marked. But we've got a vertical angle that's also 60 degrees. What is the measure of those other two angles that are not marked, that are kind of flanked, that kind of flank those 60-degree angles? Quick calculation. And you should come up with 120 degrees because we've got a straight line formed. One of them is a 60-degree angle. One of them has to be 120 degrees then in order for that to be 180 degrees or a straight angle. So when secants intersect inside of a circle, then to find the measure of the angle, we average the arcs that are cut off by that secant. We will prove that theorem in the exercises, and we'll do a couple practice problems as well. The second theorem in this chapter has to do with secants that intersect outside of the circle. So the secant and another secant, and here they are intersecting way out here, all right? And we'll call that point P, where they intersect, and again we'll have AB and CD on these secants. All right, the picture in your book, again, if you look at figures 3 and 4 at the top of the page, you can see that in figure 3, well, let's look at this picture for a minute here first. In this case, I have this one angle, this angle at P, cuts off two different arcs. Do you see it cuts off arc AC on the near side of the circle, and it cuts off arc BD on the far side of the circle. So now in your book, in figure 3, it labels this as a 140-degree angle, and this is a 20-degree angle, and it tells us that this angle here at P, the book calls it something else, is a 60-degree angle. What is the relationship between 140, 20, and 60? You might not know. How about if you subtract 140 minus 20? What do you get? 120. Good. And 60 is half of 120. In that fourth figure there, we've got two angles that are cut off. One of them is a 160-degree angle, and the other arc is a 40-degree arc. And similarly, 160 minus 40 equals 120 divided by 2 is 60. So I have a 60-degree angle because it cuts off these two arcs. And so when I have two secants that intersect outside of the circle, I'm going to take half of their difference in order to find the measure of that angle. And we will prove that theorem and do some of the exercises associated with it in the set 1 exercises. I wish that I could ask if you have any questions now, but I guess it's not going to help if you do. So we've looked at a bunch of different ways that line segments and circles can interact, and this is just another set of ways that they can interact with each other. Let's turn the page over to page 512 and go through this proof of Theorem 64, that when we have secants that intersect inside of the circle, that the measure of the angle is the half the sum of the intercepted arcs, or the average of those intercepted arcs. So I'm going to have this time secants AC and BD. They intersect at point P here in this inside of the circle, and we are going to look at this angle here. This angle that I have marked, angle APB, intercepts two arcs as it goes through the circle, and intercepts arc AB, and it intercepts what other arc? You are correct if you said DC. All right, so it intercepts those two arcs. I don't know the measure of either of those arcs, but I don't need to know that in order to prove this theorem. All right, first thing I'm going to do is I'm going to draw DA. How come I can draw DA? 2 points determine a line. Very good. Secondly, I'm going to look at angle APB. Angle APB. And I know that angle APB has what relationship to this triangle, the triangle ABP? What is the relationship of this angle to this triangle? It is an exterior angle. Okay, so that's super helpful because we know that an exterior angle of a triangle is equal to the sum of the two remote interior angles. So I'm going to call these, for simplicity's sake, angles 1 and angle 2. And I'm going to say that angle APB equals angle 1 plus angle 2. And why is that? That's because the exterior angle of a triangle equals the sum of the two remote interior angles. All right, number 3. Angle 1 then equals half the measure of arc AB. Why does angle 1 equal half the measure of arc AB? What kind of angle is angle 1? Angle 1 is an inscribed angle. Its vertex is on the circle and its sides extend through the circle in 2 different points. So angle 1 is half the measure of arc AB. And what about angle 2? Angle 2 equals half, is also an inscribed angle, and it is equal in measure to half its intercepted arc, which is arc DC. So angle 2 equals half the measure of arc DC. All right, number 4 then. It says, it looks kind of complicated. It says angle APB equals half the measure of angle of arc AB plus half the measure of arc DC, and that is simply substitution. I've substituted this for angle 1, and I've substituted this expression for angle 2. And so by substitution then, we have proved exactly what we wanted to prove, that angle APB equals half of arc AB plus half of arc DC. And you can factor out that 1/2 and have that be, let me write it over here, 1/2 the measure of AB plus the measure of CD. Like that. Okay, very good. Number 5. In the figure below, chords AB and CD cut the circle into 4 arcs whose measures are given in terms of x. So the first thing we have to do is to find x. How big is x? Well, let's see. Let me draw this picture here to help us think through it a little bit. So I've got C, A, E, D, and B. This is x degrees. This is 3x degrees. This is 2x degrees. And this is 4x degrees. And my picture obviously is not drawn to scale. Well, okay. So my question for you is, how many degrees are there in a circle when I go all the way around? 360 degrees, right? How many x's do I have in that 360 degrees? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 x's. So each x, if 10x degrees is 360, then x equals 36 degrees. All right, therefore we need to find the measure of the 4 arcs. So arc AC, and that just means those minor arcs that are shown. I know you could make a variety more arcs there, but Arc AC then is 36 degrees. Arc BD is twice of 36 degrees, which is 72 degrees. CB is 3 times 36. 36 times 3 is 108 degrees. And 4x is arc AD. 4x is going to be twice of 2x, so 144 degrees is the measure of arc AD. All right, very good. Next set of problems has to do with proving that second theorem that we learned. And so in this case, we've got a circle and we have a secant angle that from secants that intersect outside of the circle like this. So they intersect at point P, and these points are C, A, and D, B. And I want to prove that this angle at P, angle P equals arc AB, the measure of arc AB, minus the measure of arc CD. So we're taking the big arc minus the little arc, and we're taking half of that. 1/2 of that measure. That's what we're trying to prove. Okay. So you might not know where to begin. That's okay. The book kindly begins for us. And it says, draw DA. So I'm going to draw DA. How come I can draw DA? 2 points determine a line. Number 9, angle 1, and they have labeled this angle 1 and this angle up here 2. Angle 1 equals angle APB, so this angle over here, I'm just going to call it P. It equals angle P plus angle 2. Why is that? Well, it's just like in that last problem that we did. Angle 1 is an exterior angle to triangle BAD, and so the exterior angle equals the sum of the remote interior angles. So angle 1 equals angle P plus angle 2. Now I can rearrange that problem and get angle P, if I subtract 2 from both sides, equals angle 1 minus angle 2. So I subtracted P from both sides and I flipped the 2 sides of the equation. I did those 2 steps here. All right. Number 11. Angle 1 equals what? Angle 1. Well, what kind of angle is angle 1? It's an inscribed angle. So angle 1 equals half the intercepted arc. So what arc does angle 1 intercept? It intercepts arc AB. That was not a beautiful line. All right, so angle 1 is half of the measure of arc AB. And how big is angle 2? Angle 2 is also an inscribed angle. See, its vertex is on the circle, and it intercepts one arc as it comes across. It intercepts arc CD. So the measure of angle 2 is half the measure of arc CD. Therefore, if I use substitution, angle P equals half the measure of arc AB minus angle 2, which is half the measure of arc CD. And by substitution, I can, so that's substitution, and then I can factor out the 1/2 and say 1/2 of the measure of AB minus the measure of CD. And there you go. I have proven what I wanted to prove. Excellent. Okay. Next, number 13. In the figure below, the sides of triangle ABC cut the circle into 4 arcs. 3 of whose measures are given. All right. Well, if I have a circle and I know 3 of the 4 measures, can I figure out that 4th one? Yes, and so can you. All right, so B, C, A, D, and E, and this is a 100-degree arc, and this is a 110-degree arc, and this is a 120-degree arc. And number 13, we are asked to find the measure of arc DE, this arc right here. So how many degrees are in that full circle? 360. And when I add this up, I've got 330 degrees. That means I've got 30 left over, so arc DE must be 30 degrees. Find the measure of angle A. Angle A out here. All right. Is angle A a central angle? No. Is it an inscribed angle? No. Is it a secant angle? Yes. Okay. Is it a secant inside the circle? No. Is it a secant outside the circle? Yes. Therefore, I'm going to look at the 2 arcs that it intercepts, 30 degrees and 110 degrees, and I'm going to take half their difference. So 110 minus 30 over 2. 110 minus 30 will give you 80. 80 over 2 is 40 degrees. That means that angle A is a 40-degree angle. Number 15, find the measure of angle B. All right, angle B. What kind of angle is angle B? It is an inscribed angle. It's inscribed in the triangle. Its vertex is here on the circle itself. It's inscribed in the circle, sorry. Its vertex is on the circle. It cuts off arc DC. How big is arc DC? Arc DC is 30 degrees plus 120 degrees by the arc addition postulate, so that's 150 degrees. If arc DC is 150 degrees, how big is angle B? Angle B is half of that, or 75 degrees. And lastly, we need to find the measurement of angle C. Now, I think there are 2 good ways to do that. You could say it cuts off this arc of 130 degrees, it has half of that, or 65 degrees. Or you could say 40 degrees plus 75 degrees gives me 115 degrees. I know that the sum of the angles of a triangle is 180 degrees, so 180 minus that 115 equals 65. Either one, totally legit. Good way to solve it. All right, I am just going to do the next set of problems, and I'm going to change your homework a little bit and have you do 22 to 44. You do not have to do the additional problems that I originally listed at the end of the chapter. Okay, let's look at this danger angle and see how that goes. A danger angle is used by navigators to avoid a hazardous region near a coast. In the figure above, line L represents the path of a ship, and points A and B represent 2 lighthouses on the coast. The hazardous region is inside of the circle. Number 17, what is the danger angle, angle D, called with respect to the circle? It is an inscribed angle. Its angle, or its vertex, is on the circle, therefore it's an inscribed angle. Number 18, given that the measure of arc AB is 110 degrees, find angle D. Well, angle D is an inscribed angle. It's equal to half the measure of its intercepted arc. Half of 110 is 55 degrees. Number 19, what is angle S called with respect to the circle? It is a secant angle. It is a secant because it is outside of the circle, and each of its sides intersects the circle in 2 points. Number 20, what can you conclude about the measure of angle S when the ship is at S? Well, what it's asking here is, how does it compare to angle D? So is it going to be the same size as angle D? No. Is it going to be bigger than angle D? No. Is it going to be smaller than angle D? Yes. Why is it going to be smaller than angle D? Well, the measure of angle S is going to be the measure of arc AB minus that little other arc that is kind of darkened in there that you can see. We don't have letters for it, but since I'm subtracting something from 110 degrees and then taking half of that, it has to be less than that 55 degree angle. And then number 21, what could you conclude about the measure of angle S if S were inside of the danger circle? Well, it's actually going to be greater than angle D at that point, because we're going to be summing 2 arcs, the 110 degree angle or arc and then the arc on the other side. And so the closer you get to the coastline, the bigger that angle is going to be. All right, very good. So your homework then starts at 22 and we'll go through 44. And that is all for now. And I will post another video on lesson 6. And there is also an algebra review, hooray, in this chapter. And I will do a separate video for the algebra review. Thanks. If you got questions, shoot me an email, let me know. I'll try to handle them. Have a good weekend. Bye.